Okay, one more slide, please. So as I said, this CPT MCM is part of our CPT tool suite, and we've always had this capacity planning tool to do right sizing. Then we had CPT SCON to help us look at server consolidation, and now we have CPT MCM. We still will use CPT SCON for PEP 2.0 environments because you still need to size the partitions. You still need to figure out what their EC and VP is. The CPT MCM is really looking at sizing your base capacity. It's a study of your per core charges, right? So the per core you have your licensing, your OS licensing, your SWAMA, your hardware activation and hardware maintenance costs that are tied to per core. That's where we want to kind of zero in on. So next slide. Okay, so what we can do with this CPT MCM is we can look at pools 2.0 before you make the investment. So this is it's essentially a sizing tool, but it can also help you see the value of PEP 2.0. And in some cases, we can show over $1 million, over €1 million worth of savings for larger environments. And we have seen that because you can really gear the amount to what your steady state is, and the peaks pay as you go. We take, as I said, historical data, scale it by RPerf, and use that as our per minute model. So we need to capture data in 1 minute samples because that's the same way that the CMC is going to measure it. So if we could take 1 minute samples and see the average physical consumption over 1 minute, then we can use that in this study. Okay, next slide. Okay, so how do we get the data? We need this LPAR util data that you may already have. If you have LPAR to RRD, you'll have 60 days worth of 1 minute samples we can take right away, and boom, we can do a study with that right away. If we can't go back in time, which is unfortunate, we can still give you a collection script, a very simple collection script that'll get the data that we need. And then we can take a look at it after a day, a week, a month, whatever. The goal is really to try to come up with a business cycle, to try to look at what would, if we took this month of data and repeated it 12 times a year for 3 years, would that be representative of your business? And sometimes in order to do that, we need to make sure we capture end of month or end of quarter, things like that. So it's important that we build the best model that we can. But even before we get the finished product, we can still see where the workloads can be peaky or not, and definitely get a good sense of where the savings is going to be. We obviously need to know the target architecture. Each of these different KEK types are going to have different cores per socket, and as you know, the frequency for the different cores per socket are going to be different due to the fact we can run fewer cores faster at the same temperature. So I need to know what that is so we can get the right RPerf scaling. We also need to know the version of AIX that you're using, because obviously if we tell you it's 2 cents a minute for AIX, that's 2 cents a minute for an AIX that's fully licensed in SWAMA at whatever version you had. So if you had Enterprise Edition or Cloud Edition, that we're extending that to each additional metered core. And then we need to know how many years you're going to own or lease the system. So the model is going to be based on that. Then we collect the data and we find the most cost-effective solution. Next slide. So the one thing to point out about this data collection is it's very unobtrusive. It's not going to be, if you're familiar with how LPAR RRD works or how LPAR util works, it's OS agnostic. It is agentless, so you don't have to install any agents. What we're doing is we're taking advantage of the fact that the HMC is going to pull the hypervisors to get these counters that tell you how many cycles were devoted to dispatching threads and executing workloads. And from that, we can do the math and figure out what the physical consumption is. So that's great. Now, the data on the HMC is volatile. So the data, the HMC is not a data warehouse, so it's going to throw things out rather quickly, which is why L part of RRD came to be. It's a way of offloading that very useful data to some persistent database. So we need to offload that in a similar fashion. If we give you a collection script, we're going to want to, run it nightly and pull a day's worth of data every night so that we don't lose that from the HMC. Next slide. Okay, so all we need to make sure is that you have the LPAR util collection turned on, and you do that with the ch LPAR util command. We can show you how to do that. We want to make sure your HMCs are using network time protocol, similar to the same requirement that the CMC is going to have. We want to just make sure that everything's lined up properly, so make sure you have the right time, because we're going to get data from different HMCs for this study, and we're going to have to shift some of the data based on time zones. And so we just want to make sure that we line everything up as perfectly as possible. We can run it once a night. There's an example of cron tab. And then the script is really as simple as this little one-liner here. So we, cycle through the HMCs, go to each HMC, cycle through the frames. For each frame, get LSLPAR util for 25 hours, 25 just to be safe so we don't lose anything. And get 25 hours worth of data at the LPAR level. And we grab all these different cycle values. And from that, we can, and you can see the example CSV file. From that, we can do everything we need to do the math and figure out what it's going to look like. Next slide. So then the next steps, we normally would say, give us the data after a day or two. We're going to take that data and we're going to give you an initial look at it and make sure there's no missing LPARs, missing frames, and everything that's in scope is appearing. And then we'll say, okay, keep it running every night. And then about 1 week, we can get a first real look at it, like a weekly cycle. And then we can show you what that looks like. And then again, we do the same thing again at 1 month or however long we need in order to get the best view of this. The other thing I just want to mention is we can manipulate the model if we need to. If, let's say, we start collecting this week, and you say, this week we have end of quarter, and next week is a typical week. We can take those 2 weeks, that's a end of quarter week and a typical week, and I could take the typical week and say, let's run that, play that back 12 times for every one time we do a peak week, and that's a quarter. A quarter looks like that, and then we can use that as our business cycle. Okay, that's it for me. If you have any questions, please put them in the chat. I'll take a look. And then Stephanie's going to show you the CMC. But we've done this for a number of clients. And as Joe said, if you're interested, we will do this for you. We will find a way to find funding for it, because we want to promote this solution, and we want to show people the value of it. So please reach out to me if you're interested, or your sales team, and we'll be happy to do it for you.